welcome back everybody. So we're going to look at what the reagents are for these reactions, again the mechanisms. So the first reaction is a bromohydrin formation, clearly, right? And so the way we are going to achieve this is by adding bromine and using water as the solvent, as we've learned. Again, I want to just make sure you're super solid on this mechanism, so I'm drawing it here again. If the Br2 gets attacked by the double bond, that's the nucleophile, and then you form the bromonium ion. Okay. Here's the bromonium ion, and now remember, like all these other three-membered ring ions, like the epoxide or the mercurinium ion we've seen, this bromonium ion gets opened up by water. In this case, is the nucleophile. And again, remember, the nucleophile attacks the more sterically hindered, the more substituted carbon, because the resonance structure of a carbocation there is better. Remember that? And so that gives you the Markovnikov product. Markovnikov bromohydrin product. But first, before you form the bromohydrin directly, what you get after the water attacks, you get again the protonated alcohol, the protonated bromohydrin, and that gets deprotonated to form by the base, for example, by more water, to then form the final product. Okay, that's reaction 1. Give you a few seconds to finish writing it. Now for reaction 2, it's a little bit more fancy. Okay, this is a hard one. So here what we have to do is first of all a mercuration, and mercuration with this in the presence of water, right, to add the OH group. Then number 2 is you have to remove, because this is actually way hard. It's basically a mercuration, a demercuration reaction, okay, in water. The hard one is coming up later. Sorry, I was confused. Okay, so I'll just remind you of the mechanism again. Mercuration, you form this, the mercuration goes with HgOAC2, so mercury diacetate. Now, one acetate leaves, you form Hg plus O acetate, right? The mercurium cation, and that is as we learned, is a great electrophile. It gets attacked by the double bond. Again, the double bond is always the nucleophile. And so then what we form is the mercurinium ion. And here I'm drawing it. There we go, right? And of course the mercurinium ion, like the bromonium ion on top, gets opened up, again on the more substituted carbon, and by water, and you form again the protonated product after, and then we deprotonate, so I'm writing it down here in the second arrow. You know now how it works, so you get to this alcohol, which still has a mercury in it. And then you have to remember that the sodium borohydride is used to take off the mercury and just replace it, reduce off the mercury, and you get a hydrogen there instead, where the mercury was, okay? So that's this one, the last reaction. Essentially what you get is you get an alcohol and an ether in the product. And here's how it works. With H+, you protonate the epoxide, like we have learned. So we're drawing the protonated epoxide here. Now next, what do you think? The methanol in there is acting as the nucleophile. It must be, it's a solvent, okay? And so that's opening up the epoxide, the protonated epoxide, and of course it's doing it by attacking again the more substituted carbon. See, always the same concept. And then what you get is you have a protonated ether you're forming. Okay? See, directly out of this arrow pushing mechanism. So the only thing you have to do in the end to get to the product is to deprotonate it, again with another equivalent of methanol. That's pretty much it. So I'm going to give you some final synthetic practice. And that's these two reactions. These are a lot more advanced, okay? You need multiple steps here. So there's a question mark for the reagent, question mark for the first product you're forming, and there's another question mark. And finally, what we want to get to is this compound. Okay, this ether, this methyl ether compound. Think about it. It's not very easy. Now this one is again a multi-step thing. So I'm drawing it for you guys here. You need to figure out all the question marks. See, what we're trying to do is go from an alcohol to just an alkane. Take off all the functional groups. Think about how you can do it. Okay, so this is a good thing to just think about. And we are gonna, if the lecture is done, I would say you think about it until Friday, and I'm gonna give you the solutions on Friday. If the lecture is not done, then just take like 5 minutes and work on it now. And then I will post a video too with the solutions. Okay, thank you.